Bonjour, mes amis! All right, we are going to take polar equations and we're going to convert them to rectangular equations. We're going to do that, but first I need to review a couple things before we can get started. I want to review circle equations first. And we learned this in geometry, and you probably won't remember it because we spent a day on it, but once I show you, you'll say, oh yeah, that's not too bad at all. So our circle equation is written like this, and notice that our HK is the second value here and the second value here, but we have to change the sign for that because that says a minus h and this is an h. And then to get our radius, we would just square root that number to get here. That probably didn't mean much to you, but I think I'll make sense of it right now. So if I have an equation like this, x minus 2 squared plus y plus 4 squared equals 16. What is the center of your circle? Well, the center of your circle is going to be the opposite of this, which is going to be a positive 2, and then the opposite of this, which is a negative 4. And then to get the radius, I have to go from the r squared, this is r squared, 16, and I have to square root it to just get plain r. So my r is going to be the square root of 16, which is, of course, 4. So now let's go ahead and graph that. So my center is 2, negative 4. So I'm going to go, that's my graph of my center point. And then I just basically need to have a radius of 4. So I'm going to go out 4 to the right. I'm going to go up 4, left 4, and down 4. There she is. That's my circle. All right, next one I want to go over is what happens if you have something like this, x squared plus, say, y plus 1 squared equals 4. Well, if you wanted to, you could rewrite this as x plus 0 squared, but it's not really necessary. You should just recognize the fact that if you don't have any parentheses, that point is going to be 0. And then again, we have a plus 1 right here, so we're going to take the opposite of that, and we're going to get negative 1. So our center in this place is, in this circle, is 0, negative 1. Again, the 0 comes from this because you can write that as x plus 0 squared. The opposite of 0 is negative 0, which is 0. Okay, and then what's our radius going to be? Well, we square root this, and we get a radius of 2. So that 0, negative 1 is located, let me change to black. My 0, negative 1 center is right here. And then I've got a radius of 2. So that'd be up 2, sorry about that, up 2, right 2, down 2, left 2, and then there I go. There she is. All right, now I'm going to review complete the square. So here are the steps right here. First, we have to make sure that our a is 1. In this case, it is. But if it's not, you should divide everything by that value in front of a to make sure it is in that. You won't have an issue in this problem that we do next. All right, write it in the form of x squared plus bx plus c, meaning that I have to take my constant and put it on the other side. So I'm going to add 7 to both sides. So that gives me x squared plus 6x. I like to leave a little space, equals 7. Okay, now I have to do b over 2 squared. I need to add that to both sides of the equation. So that's why I left that space here. Well, what is b over 2 squared? Well, our b is 6. So if b equals 6, then b over 2 squared is going to be 6 over 2 squared, which is 3 squared, which is 9. So I'm going to kind of keep this red because this is red right here. So we're adding 9 to both sides. Okay. So what does that give us? Let's go ahead and reduce this. We're going to have x squared plus 6x plus 9 equals 16. Now, basically, if you want, you can just put I am good at this and factor it and say what adds to 6 and multiplies to 9. Well, what does add to 6 and multiply to 9? I would say 3 and 3, right? So you could say, oh, it's both 3 and 3, so it's going to be x plus 3 times x plus 3 equals 16, or you can think of that as x plus 3 squared equals 16. I feel like you're much better at that than what I'm about to show you. There's a little trick here that if you can't figure out what these are, what you do is you just write b over 2 here. Well, what is b over 2? Well, b is 6. So if I wanted to find what b over 2 was, b over 2 is going to be 6 over 2 is going to be 3. And that's what tells me what this number is right here. Okay, so that's how I factor that by complete the square. And maybe you can already see the connection between the two. All right. All right, so we're going to use these helpful formulas, and we've already gotten them before. Remember, we used these formulas to convert from polar to rectangular, so I wrote them right here. And then we use these formulas to go from rectangular to polar, and those are located here and here. And I think I added a couple more. What did I add? I added this one right here, which is really just square rooting. Oh no, we had that one. I took this one and I squared both sides, so r squared is r squared, and squaring a square root disappears the square root here. And then I also added tan theta equals y over x, which comes from here, right? If I write tangent of theta, that's going to be opposite over adjacent is y over x. So do you have to derive those? No, but I'd feel guilty if I just said, hey, they're true, right? So those are helpful formulas. Now, before we get started on these, I just want to alert you to the fact that we could do many different types of these problems, and it certainly does get very complicated. But I'm going to limit it to just these examples, and the problems in your review packet and your assignment and the test are going to be pretty darn similar to these. So yes, these do get much more complicated than what we're doing, but you're going to get the general idea of what we're doing anyway. So we're going from a polar equation to a rectangular equation, and the whole idea of a polar equation is very abstract anyway. It's basically saying, hey, I can graph an equation on a polar coordinate grid, and that's crazy, and you would have everything in terms of r and theta, as you can see here. But we have such a hard time conceptualizing that we want to get rid of the r's and thetas, and we want to have everything in terms of x and y's so we can be in a rectangular equation, which is what we've done our entire lives in math, have x's and y's in equations. So some of these require tricks, but since we're duplicating these problems, it will be a good idea to memorize these tricks. So the first one is we're really trying to get a match. And if I multiply r equals 8 sine theta times r on both sides, the trick that I'm doing right here is cool because when I multiply by r on both sides, I get r squared equals 8, and I'm going to take that r and I'm going to put it inside 8r sine theta. This is a cool trick because now I have two matches. When I say a match, I mean I see an r sine theta in my problem, and I also see an r squared in my problem. So now I'm going to substitute in. So what is r squared? Well, r squared is x squared plus y squared. So I'm going to write this as x squared plus y squared. And what is r sine theta? Well, it's y. So I'm just going to write this as 8y. Okay, now I'm going to go ahead and set this equal to 0. I'm going to subtract 8y from both sides. And I'm going to get x squared plus y squared minus 8y equals 0. Now you might say, Ms. Sorensen, you left a pretty big space after the negative 8y, and the reason why is because this is actually a circle equation, but it's not clear right now what it is. And this can be a question on the SAT. It leaves something like that, and it says, find what is the center of the circle, or what's the radius of the circle? And I always find these to be some of the hardest ones on the test, but if you know how to do this, you know how to do those problems. What we're going to do is just isolate this y squared minus 8y, and we're going to do complete the square with it. Okay, now we don't have anything to add to the other side, but we do need to do b over 2 squared. So again, my b is the number in front of the variable right there. So our b over 2 squared is going to be negative 8 over 2 squared, which is negative 4 squared, which is 16. So I need to add a 16 here, and I need to add a 16 here. So that's going to give me y squared minus 8y plus 16 equals 16. Now, if you want, you can just go ahead and do the I am good at this, and you would find that the answer to this would be a negative 4 and a negative 4. Or you could do the b over 2 method, and if you do b over 2, that's going to be negative 8 over 2, and you get equal to negative 4, which really means that you've got y minus 4 times y minus 4, or y minus 4 squared equals 16. But I feel like you guys prefer the AM method. Up to you. All right, so now that you've got that, I'm going to go back, and I know that this underlined thing is the same thing as this right here. And if you want, you could subtract the 16 to the other side, then add it, but we don't need to do that. We basically just need to replace this and say x squared plus, and it's going to be y minus 4 squared equals 16, right? Because this had a 16 on the right side of the equation. Well, what does this look like? This is a circle equation. Okay, this is a circle equation with what? A radius. So this is a circle with a radius of 4, because I square root that, and a center of 0, 4. Where did I get the 0? Well, we talked about when that's a 0. How do I get the 4? It's the opposite of minus 4. So we have now taken our polar equation and we've written it in rectangular form, which is just xy form. And not only do we know that it's x squared plus parentheses y minus 4 squared equals 16, we also know that it's a circle with a radius of 4 and a center of 0, 4. You would need just this to get it right on the test, but I think it's useful to know what you're getting as an answer. I think it's kind of cool. All right, let's try another one. Theta equals pi over 6. Well, what can I get theta to look like? Well, I'm going to use this one right here. I'm going to take tangent of both sides. So this is going to give me tangent of theta equals tangent of pi over 6. Okay. Well, what is tangent of theta? Well, tangent of theta is equal to y over x, right? Tan theta equals y over x. So I'm just going to write this as y over x is equal, and what's tangent of pi over 6? Well, I've got to go to my pi over 6 and do sine over cosine. So that would be 1/2 divided by root 3 over 2, which is equal to 1/2 times the reciprocal, which would be 2 over root 3. So my 2's are going to cancel, and I'm left with 1 over root 3, which hopefully we have memorized now. If we rationalize that, we get root 3 over 3. Okay, so this is going to be root 3 over 3. And now, I mean, how do we usually write an equation that's just linear? We would just write it as y equals. So in this case, I'm just going to multiply by x on both sides. The x's cancel, and I'm left with y equals root 3 over 3x, and I'm done. Basically, that ends up being a line, which honestly makes a ton of sense because you're basically hitting all the pi over 6's in your graph. Example 3 is definitely the easiest one of the group. So a radius of 5, if you think about what that looks like, that's just going to be, it's just going to be really a circle with a radius of 5. But let's confirm that we know that that's true by using our helpful formulas. Well, here we go. We know that r is equal to the square root of x squared plus y squared. So I'm just going to have square root of x squared plus y squared, and I'm just going to have that as 5. Next thing I'm going to do is I'm going to square both sides, and this is going to give me x squared plus y squared equals 25. And we're done. What did I just find? I just found a circle with a radius of 5 and a center at 0, 0, which totally makes sense when you think about graphing a radius of 5 on the polar coordinate. All right, here we go. Let's try another one. So this says r equals 9 secant theta, and the first thing that I would do is rewrite this as r equal 9 over cosine theta. And the next thing I would do is I'd multiply, and sorry, I kind of skipped a step there. Everyone knows that secant is 1 over cosine. That's why I did that. But now I'm going to multiply by cosine theta on both sides. The cosine thetas cancel, and I'm left with, I'm just going to rearrange this, if that's okay with you, as r cosine theta equals just plain old 9. Well, what is r cosine theta? It's just plain old x. So this is x equals 9. So if we were to graph this right here on our polar coordinate grid, we would get, if we just graphed it in rectangular equation, we'd get x equals 9. Kind of cool that these two equations are exactly the same thing. They're just represented on a different graph. All right, example 5, a pretty important one. Hint, hint, nudge, nudge, winkety wink. What we're going to do here is we're going to multiply by the denominator. So let me just rewrite this down here so we have more space. Okay, I'm going to multiply by 1 minus cosine theta. I'm going to multiply here by 1 minus cosine theta. My r is looking funky. Well, obviously this cancels here, so I'm left with just a 2 on this side. And then here, I'm going to throw that r on the other side, r times 1 minus cosine theta. You probably have an idea of what we do next, but it's your favorite thing to do. It's the distributive property. So that's going to give me r minus r cosine theta equals 2. Now let's go ahead and substitute. What is r equal to? It's the square root of x squared plus y squared. And then what's r cosine theta? It's x. So I'm just going to have minus x equals 2. The next thing I like to do is add x to both sides. So this is going to give me square root of x squared plus y squared equals, that's gone, x plus 2 or 2 plus x. I kind of like x plus 2 better. And then the next thing that we're going to do here is we're going to square both sides. So I'm going to put a square here, and I'm going to square this whole thing. Well, what happens when I square a square root? It disappears. So I'm just left with x squared plus y squared. And then what about this? Well, that's FOIL, or that's box method, whichever one you choose. So that's first, outer, inner, last. So we'd get x squared. Then an outer would give me 2x. An inner would give me 2x, and a last would give me 4. So this is x squared plus 4x plus 4. And most of you can do that in your head at this point. So that's x squared plus 4x plus 4. Now, like we usually do is we usually solve for y unless it's a circle equation. So I'm going to subtract x squared from both sides, and it cancels here, and it cancels here. So I'm left with y squared is equal to 4x plus 4. And then how do I get rid of a square? Well, obviously I square root both sides, and I'm left with y equals the square root of 4x plus 4. And I'm proud of you for remembering this, but it is a plus or minus, because when we square root a square, we can get plus or minus for our answer right in here. All right, so that's going to be our answer for that. Let's do one more of those. I know that those are a little bit tricky, and hint, 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 it's very important too. All right, so I'm just going to multiply by 1 minus cosine theta here. 1 minus cosine theta. And so that cancels, and here I'm left with r times 1 minus cosine theta is equal to 5. Distribute through, I get r minus r cosine theta equals 5. The r becomes the square root of x squared plus y squared. And then the r cosine theta becomes an x. Don't forget the minus right here. And then that's equal to 5. Add x to both sides. You don't want to square right away. It's going to be wicked complicated if you try to FOIL like that with the square root in it. So that cancels, and I drop down my x squared plus y squared that's being square rooted, and I'm left with x plus 5. We're going to square both sides now. That's going to give me just an x squared plus y squared equals. Foiling this one, I get x squared plus 10x plus 25. I'm going to subtract x squared from both sides. I'm left with y squared is equal to 10x plus 25. I square root both sides, and I get y equals plus or minus the square root of 10x plus 25. Congratulations, this is the last of the new content that you will learn from me in pre-calc on a computer. Super proud of you for getting through this whole thing. Thanks.